Hello बच्चों, let's read this question. Question says standard Gibbs energy of reaction, that is del Rg, at a certain temperature can be computed as del Gr is equals to del H minus T del S. Here del Gr is standard Gibbs energy of reaction, del Hr is standard enthalpy of reaction, and this is equals to standard entropy of reaction, the del S. And the change in the values of del Hr and del Sr for a reaction with temperature can be computed as follows. Del Ht2 minus del Ht1 is equals to del Cp naught T2 minus T1. Del Rs T2 minus del Rs T1 is equals to del Cp ln T2 by T1. Del G is equals to del H minus T del S by del G is equals to, and by del G is equals to minus RT ln K equilibrium. Consider the following reaction. CO gaseous plus 2H2 is in equilibrium with CH3OH. The given data is enthalpy, change in enthalpy of formation for CH3OH is equals to minus 201 kilojoule per mole. Change in enthalpy of formation for carbon monoxide gaseous is equals to minus 114 kilojoule per mole. Entropy for CH3OH gaseous is equals to 240 joule per Kelvin per mole, and entropy for H2 gaseous is equals to 29 joule per Kelvin per mole. The entropy for carbon monoxide gaseous is equals to 198 joule per Kelvin per mole, and the molar heat capacity at constant pressure for H2 is equals to 28.8 joule per mole per Kelvin. And molar heat capacity for carbon monoxide at constant pressure is equals to 29.4 joule per Kelvin per mole, and molar heat capacity at constant pressure for CH3OH is equals to 44 joule per Kelvin per mole. And ln 320 divided by 300, it is equals to 0.06, all data at 300 Kelvin. Del Hr, that means change in enthalpy of reaction at 300 Kelvin for the reaction is, options are minus 87 kilojoule per mole, 87 kilojoule per mole, minus 315 kilojoule per mole, minus 288 kilojoule per mole. Now we have to conclude the answer in this, that what we have to calculate is, we have to calculate change in enthalpy of reaction. So we can write our key concept. Firstly, we will write our reaction, that is CO gaseous is plus 2H2 gas is in equilibrium with CH3OH gas. Now in this we can write that here del Hr, that is change in enthalpy of reaction or standard enthalpy of reaction, we can calculate that summation of enthalpy of formation of product minus summation of enthalpy of formation of reactant. Here enthalpy of formation of reactant, here these are in standard states, so we can substitute the values here now. Here in CH3OH the value is given, that is minus 201 kilojoule per mole, so we can write here it is equals to minus 201. Now minus here this H2 is present in standard state, so the value for standard value for formation of H2 is equals to 0, and for carbon monoxide it is given that minus 114 kilojoule per mole, so we can write here minus 114. Now we can calculate minus 201 plus 114, that comes out to be minus 87 kilojoule per mole. So this will be the value of standard enthalpy of formation change at 300 Kelvin for the reaction, which is given in option A. Hence option A is the correct choice for this question. Hope you understood it well. All the best and thank you.